Thank you for tuning into this presentation where I'll discuss our initial preclinical results using a new tool for conscious colon activity monitoring. I have no disclosures. Currently, the study of neural mechanics underlying bowel function during natural behavior such as eating, movement, and defecation is challenging. Without versatile monitoring systems, catheter-based gut manometry generally relies on either restraint of conscious animals or the use of anesthesia. Wireless endoscopes traverse the entire GI tract and prevent monitoring at the same colon location. The few available telemetric systems involve major surgery and have only unimodal sensor probes. Our goal in this work was to develop a catheter-free, wireless sensor for monitoring colonic activity during neuromodulation studies. To enable multimodal data collection with a route to endoscopic implantation, we developed the Colonic Monitor of Conscious Activity, or ColoMoCA. The ColoMoCA was designed to enable conscious, untethered data recording of colonic activity during natural behavior. After implant, the ColoMoCA wirelessly transmits colonic pressures and electrical properties of stool over multiple days. In this study, we evaluated the accuracy of the ColoMoCA compared to microtip catheters acutely in conscious swine and in awake, untethered swine over several days. Future research with this device will include an implanted pulse generator to evaluate how different neuromodulation patterns influence colonic activity. The ColoMoCA included battery-powered pressure-sensing electronics and stainless steel electrodes. The pressure sensors allow the device to measure pressure waves between neighboring colon segments, and the electrodes provide insight into bowel volume and stool properties. Here you can see two pressure sensors on the ColoMoCA compared with two microtip pressure catheters taped alongside. The electrodes transmit a small current through different lengths of stool so that changing stool volume or composition may be detected. The ColoMoCA battery is wirelessly recharged at 10 to 20 centimeters and has a battery life of about 40 hours per charge. While in use, the ColoMoCA transmits data 30 centimeters away to a radio worn by the animal. Polymer-based packaging is used so that the ColoMoCA is flexible and can move with tissue while sutured to the colon wall. Experiments were performed at 2 sites in adult Yucatan mini pigs. For acute ColoMoCA insertions, non-anesthetized animals were transferred to a restraint cart. The ColoMoCA and microtip catheters were taped together to keep their respective sensors aligned, and then the instrument bundle was inserted into the proximal colon via a cecal stoma. Reference pressures from the microtip catheters were collected by a data acquisition system, and ColoMoCA data were recorded by a radio worn by the animal. Data were recorded for approximately 30 to 40 minutes per session 3 times, and the animals survived after all procedures. For chronic survival implantations, ColoMoCAs were implanted through a 1 centimeter incision in the colon and sutured to the colon wall. Conscious daily recordings of up to 2 hours began the day after implantation using a radio placed in a jacket worn by the animal, as shown here. Colonic pressures and electrode readings were made with animals fully conscious and freely moving, with data recorded by the wireless radio worn by the animal. During recordings, the animal ate food, walked, urinated, and defecated freely. Animals carried the ColoMoCA implant for up to 7 days, after which devices were explanted in a terminal surgery. Acutely, we obtained 100 minutes of ColoMoCA data with simultaneous microtip catheter measurements. 4 sensors were measured simultaneously, 2 microtip catheter sensors and 2 ColoMoCA sensors. Pressure recordings were analyzed independently for all sensors, in which we quantified contraction amplitude, duration, and period between contractions. This independent analysis was used because head-to-head comparison between microtip and ColoMoCA sensors showed varying degrees of correlation. As depicted here, sometimes the sensors showed excellent correlation and other times weak correlation, despite being located in the same colon segment. We think this may have been caused by the local forces of stool, which exerted unique, localized force on the different sensors. Despite the lack of consistent correlation, in an independent analysis, all sensors statistically agreed in measures of colonic activity. Here's an example recording from the chronic study. This shows pressure recordings from the proximal and distal ColoMoCA pressure sensors with simultaneously conductivity measurements from the stool contacting electrodes. Pressure data were analyzed as in the acute study but without reference sensors for comparison because these recordings were made untethered. Because the electrode sensing methodology was newly developed by us for this sensor, we do not yet have an established data analysis protocol. However, we believe that the very slow rhythmic activity indicates stool movement. These rhythms are most apparent on electrode 1 and 2, and we are currently validating this theory with bench phantoms so that we can better understand how the electrodes describe colon contents. To conclude, small wireless sensors can remain in the bowel for at least 7 days, permitting catheter-free, untethered recordings of colonic pressures and conductivity of bowel contents. Comparable colonic luminal pressure features recorded by the Colomoca and the standard manometric tools in an awake pig support the use of Colomoca for in vivo monitoring of intestinal motility. As a research tool, these sensors can improve neurophysiological research of the pelvic organs, particularly when paired with similar sensors placed in the bladder. Preliminary data from our bladder sensor was presented at last year's ICS meeting. Finally, clinical translation of this technology could enable rectally inserted catheters for chronic diagnostic testing in humans without catheters. Thank you very much for viewing this on-demand abstract, and I look forward to hearing any questions or feedback.